kiddos. So it is the day before break. We just have to get through math class today, and then we're one step closer to Thanksgiving break. So go ahead and get your notebook for me. Today we're going to be doing notes on determinants. Determinants. I'll have to double check that spelling because that doesn't look right to me. Determinants of matrices. So a determinant, I'm going to abbreviate it DET. That's how it's abbreviated a lot. A determinant helps us find the inverse of a matrix. So inverses are going to be our next learning target, but essentially it is two matrices that multiply together give you the identity matrix, which you can think of that as like the matrix form of the number 1. But we'll talk more about that next week after break. So what we're trying to do is find the determinant of 2 by 2 matrices and 3 by 3 matrices. So when we're dealing with 2 by 2 matrices, we're going to have something like this. We're going to be given this matrix with 2 rows, 2 columns, -1, -5, 4, and 4. So that is our matrix, and we are asked to find the determinant of that. So for the rule for any 2 by 2 matrix is if you're trying to find the determinant, you can think of the matrix as A, B, C, D. And the way that you find the determinant is AD minus BC. So A times D minus B times C. So whatever is in your first row, first column, that's A, and then so on and so forth for your other letters. So over here, you can think of it as X's essentially. So we're going to have, this is our A and our D. So we're going to have -1 times 4 minus our B and our C. So we're going to have 4 and -5. So that's going to give us -4 minus -20. -4 minus -20 is the same thing as -4 plus 20. So our determinant of that matrix is going to be 16. So this is going to be a tool to help us next week. So this will probably make more sense next week, but we have to learn how to do determinants first before we can find inverses. Another way to show that you want to find the determinant of something is like your matrice, it might have absolute value bars around it. That also means find the determinant. We'll do another example real quick. So if we are given this matrix, we're given -5, -1, -5, -2. And we want to find the determinant of this one. You also might see it as DET with all of this in parentheses. We're going to have -5 times -2. That's going to give me 10 minus -5 times -1 is going to give me 5. So 10 minus 5, my determinant is going to be 5. Okay, so this is the rule for when you're dealing with 2 by 2 matrices, 2 rows and 2 columns. So the rule gets a little bit different when you're doing 3 by 3 matrices. So I'm going to go ahead and, well, I thought I had more paper than this. Let me tell you. I'm going to go ahead and move this. So when you're doing 3 by 3 matrices, let's say we are given -8, -2, 4, -6, 6, 4, 7, -6, -4. So when we are given the 3 by 3, the rule's a little bit trickier, so please pay attention to what I am saying. You're going to focus on the numbers that are in your first row. These are the most important numbers. So if you're going to start with your first number in your first row, first column, you're going to go ahead and pull that out. So I have -8. we're going to have to multiply that by, well, hang on, let me get some colored markers. So you're going to pull out that -8, and then essentially you're going to want to cross out this row and this column. So I did a light color, that way we can look back at what those numbers are later. So we're going to have -8, and we're going to multiply that by our new 2x2 matrix of this created. So this is going to be 6, 4, -6, -4. Then we're then going to have to find the determinant of this little matrix, but we'll get there in a second. So once we get that, we're going to move to our second number. The biggest rule you have to remember is this second number right here. If it's negative, it has to become positive. If it's positive, it has to become negative. So instead of pulling down a -2 here, I'm going to hit a +2. And then I'm going to go ahead and I'm going to mark out the column that one goes with and the row. And then I'm left with this -6, this 4, this 7, and this -4. That's what's going to give me my 2x2 matrix for this one. So I'm going to have -6, 7 in the first column, then 4, -4. Okay. And then lastly, we have a 4. That sign can stay the same. So +4. We're going to mark out this column and that row. And then our matrix is going to be what's left over. So it's going to be -6, 6, 7, -6. I know that is confusing. Please go back, rewind, and listen to me explain that again. So now that we have this, we're ready to take our determinants. So remember the 2x2, it's A times D times B times C. So we're going to bring down that -8. And then we're going to have all of that times 6 times -4 is going to give me -24, minus -6 times 4 is going to give me -24, plus 2 times -6 times -4 is +24. 7 times 4 is 28, so -28, plus 4, and that's going to give me -6 times -6 is 36. 7 times 6 is 42, so -42. So this is going to give me -8 times 0 plus 2 times -4 plus 4 times 36 minus 42 is going to give me -6. This is going to give me 0 plus -8 plus -24. Whoop, you all can't see that, sorry. 0 plus -8 plus 24, and that's going to give me -32 as my determinant. So my determinant is going to equal -32. So we're really going to focus on doing the 2x2s. You'll have 5 of those to do, and well, you'll have 6 of those to do, and you'll have 2 3x3s to do, because I know those are kind of confusing. But essentially, if you know how to do a 2x2, you know how to do a 3x3. You just have to remember that kind of wonky rule. So again, please make sure you are taking these notes and keeping up with them, as well as you're utilizing me and Mr. Mason for help if you need it. Please hop on the Google Meet if you have any questions. But if you don't, hope you'll have a lovely Thanksgiving break. Stay safe. Eat a lot of turkey, eat a lot of pie, whatever you do for Thanksgiving. I hope you have a great Thanksgiving. I hope you have a great break from school. You all have earned it. If you need anything at all, please reach out. But I hope you all have a great rest of your day, and I'll see you on Monday.